This is my lab for oscillations, my table of contents. So for the purpose of this lab was to analyze how energy transitions from kinetic to potential in a spring mass system. And to do this, we use two modeling tools, Tracker and GlowScript. Tracker is a video analysis software that allows us to get position and velocity data, and GlowScript is a computational modeling program that allows us to predict the motion and the energy of the system. This lab is based on the fundamental physical principles of Newton's second law and the kinematic equations for position and velocity. And throughout this presentation, I'll refer to those three formulas. Our prediction is that the computational model would match the actual experimental data, which would prove the conservation of energy. And as you will later see, the model was actually very close to the experiment, and the error is likely negligible. So for this lab, our system is a spring and a mass. The mass has a mass of 0.402 kilograms, and the forces or the surroundings are the force of gravity and the spring force, and I also have those formulas shown. As for the initial conditions, the relaxed length is 0.123, the spring constant is 6.83, and these are all calculated by Professor Greger in the video that he already gave. And you can't see, but the video, the mass is released right when Professor Greger lets go of the mass, because that's we want to remove the force that he also applies. And for the initial conditions, in the y direction, there's a spring force pointing up and a force of gravity pointing down. And the two primary forces we're also just going to consider is the force of gravity and the force of the spring throughout the whole motion of the spring mass system. And the axes, which you also can't see, but are at the top of the spring, so where it's connected to that wall, essentially. Okay. Also shown is the x position data and the y position data. For the initial conditions for the computational model, so the initial positions are just taken from the first value from our tracker data, and the velocity should be 0 when you start, because we are holding the mass and then we let go, so it should start at 0. And then also in the initial conditions are the relaxed length, the spring constant, and the formulas for the spring potential energy and the potential energy of gravity. And then in my calculation loop, I use the position update formula and the velocity update formula, and I'm constantly calculating the net force, which changes. And also I'm updating the spring force, because spring force is dependent on where the mass is, essentially. And then I'm also calculating how energy changes. As for the graph, the top graph shows all the types of energy, so our delta K, delta potential energy of gravity, and our delta potential of spring. And below is the x position and the y position data. Comparing the data, you can see that they're roughly the same. So for our y position, we're going from about negative 0.76 to negative 0.65 for both the experiment and the model. And then for the x position, we go from about negative 0.12 to positive 0.12, and that's the same for both the model and the experiment. So looking at this larger, without looking at too many decimal points, you can see that the data actually matches pretty closely. Sources of error. So the first source of error is that this is not an isolated system, meaning that there could be some small forces that are acting on the system. The second source of error is that the spring might not be a perfect elastic spring, meaning that if the spring is old, maybe the coils are not working as supposed to, and there's maybe some more stretch than it should have. The last source of error is that in Tracker, you have to manually point where the center of mass is, and so there's also human error where, depending on where you click, which could change the data slightly. For the what does it mean questions, you can see that the energy principle is satisfied because the delta total energy stays constant throughout, meaning that the energy is conserved throughout the experiment. And for the period of oscillation, you can see that for the x position, it's 24.849, and for the y one, it was 25.450, and the percent error was 2.36%. So the two estimates are very similar, and the only difference we can associate to being negligible, and we can say that is maybe possibly due to the fact that in Tracker I'm manually clicking it. So depending on where I'm clicking, there could be some changes. Also, if there's some external forces, you're going to change the movement of the spring, which would change the period of oscillation. And thank you.